Welcome, one and all, to our lesson on systems of linear inequalities. And I have my system of linear inequality right here. This is what I do at night. I play this system of linear inequality. There's lots of good games on it. Comes with a controller, a couple joysticks, an X, Y, A, B button. It has it all. But that's not what a system of linear inequalities is. That's an Xbox that I just put a couple words on. System of linear inequalities we're going to talk about today are kind of like systems of equations, only dealing with inequalities. So we'll talk about the one method that'll work to solve those systems every time, and do some examples. So our learning targets, our objectives, or our learning targets for today. And again, I'm going to draw my little target. Sometimes I draw it and it doesn't look very good, but this is going to be fabulous, just like I expected. One would be to solve systems of linear inequalities by graphing. So like maybe gives away the one method already. And the second one is to model real-world situations using systems of linear inequalities. So for definition's sake, a system of linear inequalities is made up of two or more linear inequalities. A solution to a system of linear inequalities is any ordered pair that makes all the inequalities in the system true. So any ordered pair that could work for both inequalities. And we're going to have there's going to be multiple solutions for these answers. So we're going to talk about graphing. We're going to talk about writing one from a graph, so going backwards, and then we're going to have an example of using them in real world. So let's start off with this graphing portion. It says, what is the graph of the system? So again, we have two equations, or linear inequalities. One of them is in slope-intercept form. The other one looks like it'd be in like standard form. And we like slope-intercept form better. So let's start by making sure that they are both in slope-intercept form. So the first one, we're good. First one, we're good. I'm going to rewrite that first one over here. Y is less than 2x minus 3. Remember, slope-intercept form would be like, we can do it with inequalities. Okay, I'm not sure why this thing is going. Everywhere my thing is going. All right, we got it. But it's in the y equals mx plus b form. Only we have an inequality symbol instead of an equal symbol. Our second one, we have to do something to get that y by itself on the left side. So what we're going to do is we're going to get rid of this 2x. And since it's added to the y, we're going to subtract 2x from both sides. Get rid of that. We have the y over here. Really, it's 2 minus 2x, but we're going to switch it around to keep that the x part in front. So it's y is greater than negative 2x. Oh, come on now. There we go. Plus 2. All right. Now, remember, when we're graphing inequalities, we graph it just like a regular line, and we look to see if it's dashed or solid. If it has the equal to underneath it, it would be solid. Otherwise, it's dashed. And then graphing, or the shading part, if it's a greater than symbol, we shade above it. If it's a less than symbol, we shade below it. So we're going to use red for the first one, blue for the second one. Y equals 2x minus 3, that's red. We're going to start at the minus 3 or the negative 3. That's our y-intercept. We're going to go up 2 and over 1, because 2 over 1 is the slope. 2 over 1 is the slope. And we will make that a dashed line. And actually, we're going to shade that one below it, because it says that y is less than. Alright, so we're going to shade this one all below it. There it is. Our next one is y is greater than negative 2x plus 2. So in blue, we're going to start at 2 because it's a positive 2 y-intercept. And then we're going to go down 2 and over 1. Down 2 and over 1. Down 2 and over 1, if I can see where I'm going here. Down 2 and over 1. This one's also dashed because there's no or equal to part. So there's our line. And it says it's greater than symbol, so it's everything above it. Now, the area that would have all the solutions to the system is the area where they're both shaded. So I have these two things here. Should have put them in here. Graph them. And then the solutions are in this intersection of the shaded portion. So the solutions, I'll use a different color, but the solutions would all be in this portion where the intersections overlap. Any ordered pair in this section of this graph would be a solution to the system of linear inequalities. All right, so I'm going to have you try one on your own here. It says, what is the graph of the system there? Why don't you graph it yourself? Remember those three steps. Make sure they're in slope-intercept form. Graph them, and then look for the intersection of the shaded areas. I'll show you the answer for this one at the end, but we're going to move on. All right, let's go backwards now. I have the system graphed, and I don't know what the system of linear quantities would be. So let's just go backwards. Let's look at what the lines would be and where the shading is. And it's kind of tough since we don't know which is which. But I think we're going to estimate here, and we're going to assume that this is the part they're both encompassing. So blue, we'll say it goes with that blue. So this line right here, this blue line, starts at 1, and it seems like it goes up 1 and over 1 every time. So the slope is 1 over 1. The y-intercept is, actually that's negative 1. So that equation would be y, and it's a solid line, and you're shading the stuff above. So y is greater than or equal to 1 over 1, or 1x minus 1. Now the red line starts at 1, 2, 3, 4, 5. So the y-intercept is 5. Slope, you go down 1 and over 1, 2. So negative 1 over 2. So our inequality to be y, we're shading underneath it, is less than, since it's a dashed line, we don't put the or equal to, less than negative 1/2 x plus 5. There is your system of linear inequalities for that one. Okay? Why don't you try this one on your own? There's actually two questions that go along with it. It says, what system of linear inequalities is represented by the graph? To give you reasoning, and it says in part A, is the point where the boundary lines intersect a solution of the system or not? So something to think about would this right here be a solution? All right, try that one on your own. I'll come back to that one at the end. All right, here's our final problem. It is a challenge one because it is a using system of linear inequalities. Word problems are always challenging, and I'll be honest, this one for me took a little bit of time to think it through and to check my work and see if it even made sense on the graph. I made a mistake the first time, but I figured it out. And we'll go through this one, but if you want to pause it and take a second to see if you can figure out any of the inequalities on your own, that'd be awesome. But it says you are planning what to do after school. You can spend at most 6 hours daily playing basketball and doing homework. You want to spend less than 2 hours playing basketball, and you must spend at least 1.5 hours on homework. What is the graph showing how you can spend your time? Well, let's start off with listing some variables. So, for instance, we're doing basketball and homework. So we could do B and H. Let's use X and Y since we're graphing it. We'll say X is basketball hours. Trust me, that says basketball. And Y is homework. So I'm gonna, whoa, didn't know I was doing that. All right. Um, Let me just group these real quick and make them a little smaller. We're gonna make an equation. Let's just start off. You can spend at most. At most means no more. It could be that amount or less. So at most 6 hours playing basketball and homework. So basketball, so X and homework Y can be less than or equal to 6 hours. Okay. we'll write that as an equation. We're going to want to put that, oops, we're going to want to put that in slope-intercept form soon enough. I don't know what's going on with this here. But there's one equation. It then says you want to spend less than 2 hours playing basketball. So basketball has to be less than 2 hours. There you go. And homework, at least 1.5. So homework Y needs to be at least. It's greater than or equal to 1.5. All right, that's it. Those are the equations. We got a couple of straight lines, whether they're vertical or horizontal there. And this one, why don't we change into slope-intercept form right away? We'll subtract x from both sides, and you end up getting y is less than or equal to negative 1x plus 6. So here's our new 3 inequalities. And we'll do black for this one, red for this one, and green for this one. So x is less than negative 2. So we go to the x of, or sorry, positive 2. And then we make a vertical line. We go opposite of, ooh, this is supposed to be dashed, isn't it? Opposite of the x-axis. And make a dash because it's less than. And remember, less than goes anywhere over here. Let's use red for the second one. Y is greater than or equal to 1.5. So 1.5 is right here. It's supposed to be red. Right here. So that line goes across like this. Oh, and it can be or it should be solid. Try to make a better line than that. But greater than or equal to means we're above it. And then the last one in green says y is less than or equal to negative 1x plus 6. So start at 6. Go down 1 and over 1, down 1 and over 1, and so forth. And that's going to be a solid line as well. If it says less than or equal to, that's everything over here. So I'm going to use blue now to show the only part that is all intersected. Goes from here. Technically it'd go on, but can you have negative time amounts? No. So all of this part is shaded in, which means all the ordered pairs would be in there. For instance, like 1 and 3. You could do 1 hour on homework or basketball and 3 hours on homework. That'd be right in here. It can be anything in here that's not on this dashed line. It's got to be on the solid lines or inside of there. So that is how you take a whole big word problem and make a system of inequalities from it. Very challenging stuff. But practice it, you'll get better at it. Before we go, I'll show you the 2 problems that I told you to do. This first one, what's the graph of that system of inequalities? So I changed the second equation to slope-intercept form, graphed them, and found this solution area here. All right, pause it if you want to take a look at the equation, or at the graphs. Second one, we're given the graph, and I found that the blue line was y is less than or equal to negative 1/2 x plus 1. And the red line is y is less than negative 1/2 x plus 1. And the answer to part B would be no. It says, is the point where the boundary lines intersect a solution to the system? No. Really, all you have to do is try the inequality in both, try the ordered pair in both inequalities, and you'll see that it won't work for the red one. Try plugging it in, it won't work, because that is actually a dashed line. It doesn't fall on a dashed line. That's just the rule. All right. So that kind of covers our learning targets for today, which, if I take away my system of linear inequality here, are right there. Please review those too, and hopefully you learned something good from this, and you can use it on your own now. Have a great rest of your day.